And then when you do your, let's say, control systems, then MATLAB is actually one of the topics or the programs that you do. And then after university, I did my first work as an automotive software developer. And I was a heavy user of Simulink. So I usually use a lot of control logic and deploy that one to a microcontroller for an automotive setting. But now I'm the applications engineering manager of TechSource. However, in terms of like specific to ROS, I did join a training long time ago in Singapore. And just to give you also the same benefit, right? That the materials that I used before for ROS is actually here. So when you go to ROS and ask for a training for ROS in any region, let's say you go to US, you go to UK, you go to Singapore, the materials that they would use is this one because it's open source, right? You don't actually need to pay to get a training for ROS. You just need to go through here, and they have some specific exercises for you to go through. So it's a lot, but this would actually give you a better idea of how to use your ROS in its bare form, because ROS is actually a C and C++ environment. But we'll make it simple in when we talk about MATLAB and Simulink, because when you talk about MATLAB and Simulink, you don't need to deal about all this stuff. Like, let's say you need to download, set up your ROS, do all these things in Linux. All right, so there's no more Linux environment here, but I would still recommend to at least be familiar with those topics. Okay. But to begin, I think I have done my introduction to myself and some references to ROS. I think we already have discussed about platform, right? So means to say you already have a robot. Sometimes these robots are actually, the robot models are actually given to you by your customers or the robot manufacturers already. So when you talk about robot manufacturers, the most popular one would be like a Kinova robot, there is another one for Husky robot. So these are given robot models. So when I say given robot models, right? If I type in Husky, ROS, this one is already saying that it has a ROS compliant. At the same time, they would already have a robot model. So if I use zoom it here, zoom it. Okay. So if I use zoom it, you would notice that they already have the Gazebo or URDF. Means to say this robots already has the robot model. So you don't need to create the platform anymore. But again, this is something that you need to check or validate from the supplier of any robots that you're going to make. All right. So we'll talk about ROS because ROS definitely is going to be the middleware, right? So when we say about middleware, it means to say we need to communicate different microcontrollers or different control systems or ECUs with your, let's say, robot, right? I'm not saying it's just going to be an autonomous robot, but let's say as a physical robot, because definitely your platform will have its own MCU or microcontroller. You will probably have another MCU for your sensing. Maybe it's a Raspberry Pi, right? Your perception might be another controller. It might be a Jetson, right? And your decision planning would be another Jetson. Jetson is an NVIDIA GPU. Your control might be an Arduino, right? So the question now is, I have all these things in place, but how do I communicate, right? And how to do that is basically we communicate through ROS. So when you build, let's say, algorithms and deploy it to microcontrollers, my experience before is that your cars by right actually use CAN or LIN. So this is basically a way of imitating what your cars are, because your cars are actually having maybe 100 or at least 3, 5, 10 microcontrollers for the late new generation cars, right? But they need to communicate in a certain platform, and one of them is through CAN and LIN. But this is like very, how is it? You need to be very familiar with the database and all that things, and it's not very open, right? But now with the progression of like, we need to be open source, we need to have open data, and we need to share these ideas, right, or concepts. ROS is really the next thing in terms of building robots. CAN and LIN is still there, but I think for open source use cases, generally people are using ROS as a communication platform or middleware, right? So our agenda today will cover pretty much how to use what's ROS and what's ROS2, and how do we get started with just communicating with a ROS platform, right? And I will have some demos. These demos are actually with a Gazebo implementation. And I will probably have a last part here wherein we are actually going to generate, let's say, a ROS node, meaning when you have a Simulink model that has maybe a control algorithm or a perception algorithm, you want to deploy it in a ROS environment, right? So meaning you don't need to have MATLAB and Simulink anymore. Everything is going to be running in C and C++, right? So let's talk about what's ROS first. So generally, as I mentioned, people have come together, made open robotics, right? And open robotics is actually, I think, if you try to check on them, their offices generally is probably in Japan, UK, Singapore, and US. And they are the ones who made ROS and Gazebo. So basically the middleware and the simulation environment as well. So there is a lot of changes in terms of ROS. I think the first one was pretty much in 2012. But you would notice like how many downloads or how many people downloaded ROS, right? From 2012 to 2018. It means to say there is a trend that people will be using ROS in their projects. One of them probably also is with papers, right? So papers is basically you come up with an idea in your master's and your PhD, you present it in a conference, and you also notice like there's a popularity of ROS usage because again, it's very easy to actually use. If you try to read through the material that I have just went through and use that material, you would notice the ROS communication paradigm is basically you will have a publisher and a subscriber. So meaning if you are the publisher, you are actually just sending the signals through the IP or Ethernet. If you're the listener, you probably just need to subscribe to that information or to that signal. But how they would write it is through a topic. So meaning you have a motor control, you want to turn the motor at certain speed or velocity, then you will have a motor slash or underscore speed. Then you probably have it as a feedback or to command your speed command or speed monitoring or something else. And the idea behind all these things is that each application or each microcontroller would have a certain topic. It will also have its, maybe depends on your architecture or depends on how you are going to set it up. You will have each one of your application having one node or maybe a combined setup. Okay, So each process, it doesn't mean is a microcontroller. It's basically the application or a combination of application, and you say this whole functionality is one node. All right. And again, some ideas, basically there are topics, there is services, there's actions and parameters. So topics is where you do something like send and receive a message. Services is basically imitating a client server response. So what I'm saying here is that your node is just waiting to get me some information, and automatically it will respond to that information. Maybe it's like a query use case, right? So it's saying, can you give me the speed? Then a service node communication means to say, okay, I'll give you the speed. If it's actions, then definitely it's like the goal, the feedback, and the result. So if you get to that, it's basically like a warning or an alarm that you already have reached that certain goal, and it will give you that value or answer. And then the last one is just the parameters. Parameters generally are constants within your system, right? So maybe a random value, or maybe the radius of the wheel, or the capability of the limits of the system. So it's basically you can set it up or you can get it. So again, in a ROS platform, they will have topics, services, actions, and parameters. So basically, this is how they exchange values and variables within node to node. Okay, so application to application. So yeah, if you go through ROS concepts or the wiki, basically you have a topic. Either you are a publisher or a subscriber or a service. So it means to say, if I call a certain response here, then it's automatically right send a feedback. Okay, so that's basically your services. Okay, maybe I posted some links here, you can go to that to understand better what are this. But definitely I would recommend to go through here. It's generally in here. Okay, services is here. So this exercise 2.0, you need to build this one up to exercise that. Okay, so don't worry about the materials. So
sorry, and
yes.
I think before we continue, we have one question.
Yep.
From Pak Sidki. You want to answer first, or you want to?
I can answer. I think it's
Okay.
relevant. So is this possible to run ROS and Windows, especially installing LiDAR package like RP Lidar, and also the same package between RP Lidar and TurtleBot? So so ROS in Windows, I cannot, definitely there is a ROS for Windows. MATLAB is actually ROS based, but once you have an RP Lidar, I do have an RP Lidar. I actually have my own personal RP Lidar. And I think when I create my own ROS node for that RP Lidar, because majority of your RP Lidar, so for people who don't know what it is, it's this one, RP Lidar ROS, right? If I just type in here. So I actually did use this one, but I need to set it up in the Linux environment. So generally what I did is I downloaded this package. So what I meant is you download their ROS Git, build this one in your virtual machine or where you are putting your ROS platform is. But I would still recommend that you are going to put it in a Linux rather than in Windows perspective, because I think it's going to be, there's no Windows here, right? Majority of this package is Linux based, right? So you can see this one is Linux. Your ROS run, this one is basically in Linux. So again, I would still recommend to still download a VM right? Like VMware Workstation 16, you install ROS there, and pretty much download this how's it ROS node to bring it out. Okay, so did I answer your question so far? So I'm stuck. So I have stuck on generate source installation with that package. I always have that some error in working, and yeah. So I would recommend just use the Linux environment. Okay, but I would definitely just use this one. There's a question.
Yes,
Yes. You can just unmute yourself. It's fine. Yeah.
silakan Pak Muhammad.
Yeah, excuse me. So
Yes.
I would like to ask a question. So I, I I actually have a background in using Arduino, and is it possible? Let's just say I want to make a model to turn forward in a robot. So how would you do that in a ROS? Because ROS is running in a Linux using let's just say Raspberry Pi. So how would you do that in ROS? You know, like how would you turn on a model? I mean, if it's Arduino, it's really straightforward. But how would you do it in ROS?
So so generally, I think later I have a example for that. Okay, for the Arduino, or maybe you have already a control system. I'll go to that. Okay. Yeah. So there is also another question from so Mohammed, I will answer that one later because I have a use case for moving a motor here. Okay. So, but before that, there's another question from Siddiqui, right? Is it possible to is the same package between RP Lidar and TurtleBot 3? Again, I would then also recommend to use ROS in Linux, right? I would not recommend to use it with Windows because majority of your example, this is like ROS Wiki, org.rp lidar, your latest material or the latest updates for this one, so you have kinetic, melodic, neotic, right? These are basically Linux based. So if you go to Windows or there's a flavor for Windows, then there might there's pretty much no official support for Windows. Okay, so this is basically all Ubuntu or Linux. So again, I don't recommend running. So maybe that's where you have some issues with running ROS with Windows. But again, because as you see here, there's no support for Windows. All right. So that's why also in MATLAB perspective, we do support ROS and ROS2, but there is some limitations. So not all ROS capabilities are actually able to do in the platform. Siddiqui? Yes. Yeah, I think you can unmute yourself. Then I'll answer it.
Thank you, sorry, I'll first. Okay. So maybe I ask again about that package. So currently I was researching about RP Lidar and TurtleBot 3 itself, but I'm stuck in using RP Lidar package. So it is possible that I change the RP Lidar with the TurtleBot 3 or something similar like that, or it is the different package itself.
So it's a different package, right? So when you have an RP lidar, is actually the component itself. It's the sensor itself, right? If you have a TurtleBot, the TurtleBot would have different topics. So when you have a RP lidar, the topics involved or the values that you can only send and receive, right? So I'll just go for this. So if I go to the code API, let's see. So normally they would give us the the values, right? So this is RP Lidar. Let's see what are the normally they would give us their here it's here. This is parameters, this is stop motor. So yeah, so this one, right? When you have a RP Lidar, this is the only signals that you can send and receive. So scan basically is like you have your RP Lidar and then it will give you your, how is it, the distance, right, of that area. So this is the scan. This is when you say stop motor, because this is a LiDAR, it's spinning, right? So that you control when to stop and start the motor, and that's about it. Okay, this is RP LiDAR. But if I go to search and ask turtle bot here, right? Your turtle bot, ROS Wiki turtle bot 3. You would notice it's not only about that. There is a lot of messages that you can control your, I'm not saying a lot, but there's a lot of wave signals that you can send to your turtle bot. So it means to say now you have the you don't now have the control of the wheels. This is basically just the RP LiDAR. RP LiDAR. And there is also another, maybe a bunch of sensors that you attach in the turtle bot. But again, your RP LiDAR is actually just this one. So if you have a turtle bot package, then why not just use it? That's fine. But again, this is just your RP LiDAR, right? Is it clear? So far, so good? You cannot just replace it because TurtleBot is this whole thing, right? Yeah.
So for the TurtleBot 3, it's literally RP LiDAR with the motor, right?
With the motor and all these things. Yeah. So if I go back to the RP LiDAR, right? As what I mentioned, right? These are basically the ROS nodes that it has. Your RP LiDAR or your TurtleBot would have like a start left motor. So something like left motor, sorry, left motor, motor command, right? Then you have a right motor command, something like that. Later, I'll go to that. I have my examples actually here.
Ian, sorry.
That talks about it. But let me move forward. Let me
Yes,
finish the presentation.
because we still need move
Okay, yeah. So I'm still here. But I'll go to that. Yeah.
Sidik dan teman-teman mungkin yang memiliki kasus sama, saya sudah berdiskusi dengan Bu Dini. Jadi mungkin kita akan coba buat nanti sesi terpisah ya. Jadi mungkin untuk saat ini kalau memang pertanyaannya related dengan apa yang disampaikan dengan Mr. Ian, nanti mungkin bisa langsung jawab. Tapi kalau mungkin tidak related, kita coba lanjutkan di sesi terpisah gitu ya, Pak Sidiki ya. Karena sepertinya seru nih, kayaknya panjang nih.
So we'll take note on the questions, then we can answer it later. Okay.
Yeah. And also, Ian, maybe we can arrange another meeting special for this case.
Yep. Yeah. Correct.
Okay. Thank you.
Okay.
Please continue.
But again, just to give you an idea, as what we've shown, right? You have a TurtleBot, you have RP LiDAR. Generally, it's about the topic or what are the services and the action that a certain equipment manufacturer provide. And basically, you just say, I'm a publisher, I'm a subscriber. But again, to give you an idea, again, please go through this one. It tells you how to create a publisher, how to create a subscriber from scratch, right? So this is something that you might want to look into to really go into ROS development or ROS programming. But anyway, the idea is basically you have ROS node 1 and ROS node 2, and you basically try to talk and submit different signals, right? So when you have ROS2, I think now the most popular one is going towards ROS2, though there are some uncertainties, or it's still in development, right? It's not a very stable platform at the moment. But the idea here is that you don't have anymore a ROS master. So you don't have a gatekeeper already, because when you say a ROS master, right, your ROS master is a high performance computing embedded computer. So it should be a system that can handle all these messages out. That's for ROS1. But for ROS2, since there's no more, means to say you can actually become when you have two ROS nodes, they can already work together. No need to have a ROS master to record all these databases, right? But yeah, let's move forward. Let's try to send signals, right? So I later I think I have some use cases for TurtleBot here, though it's in Gazebo perspective, but at least we'll go through that. Like, what are the signals? What are the topics? So generally, if you use ROS, again, you either are familiar with C, C++, Python, or any other programming language that tells you to program in, that is able to program in ROS. So MATLAB is just one of them. But when you are developing something in robotics, right, and just imagine you're going to do it in C and C++, it might take you some time to build that one in C or C++. As you've noticed here, right, in the actual material for this one, when you go to perception, in perception, right, it will be in C and C++ using certain certain libraries in C, which is PCL, point cloud library, but it's going to be in C and C++, not in Python, not in MATLAB, but your ROS is going to be running on C or C++. So in terms of using it in MATLAB, there are multiple ways. So one is basically you just do a ROS bag. So generally, majority of your equipment manufacturers or component manufacturers will have its own application and store and save the signals and, let's say, variables in a ROS bag data. So an example is I have a RP Lidar. I also have, let's say, the Intel RealSense. Normally they would support what we call as ROS bag. So I can then perform some offline programming or offline evaluation of the system. So the other thing that you can do is do a desktop prototyping. Means to say your ROS equipment is running. It might be in Gazebo or it can be an actual hardware, and MATLAB can directly connect or communicate to that system. The next one is that you have a MATLAB algorithm. As what I mentioned, your ROS is by right C and C++, not Python, not MATLAB. But what we're going to do with your MATLAB algorithms is we convert it to C and C++, wrap it in a ROS node that should be run in an embedded device. Okay, so this is the three things that you can do. One, just do post-processing, meaning you save some files, some ROS bag, then run it in MATLAB. Second one is prototype. So you have an online communication, a cost simulation activity with the simulator or the hardware, and run it together with MATLAB. The last one is we generate a ROS node, but your algorithm is also converted to C and C++, and now you can communicate independently without MATLAB and Simulink. All right. So how would this look like? So in MATLAB, we do have some templates, but to give an idea of how it's going to be, if you're familiar with MATLAB scripting, you need to initialize it first. Where is your ROS master, right? Do take note, we need to have a ROS master. We need to specify the IP address of that. So a virtual machine would have an IP address, then you put it here, right? And then what is the ROS topic? right? If I have this ROS Master, they would tell me what are the signals that I can subscribe and what signals I can publish. Then if I want to read the data, the last message, then I can just say my sub latest message. Then I get that data. Then maybe this is going to be your algorithm. It might be a planning algorithm or a perception algorithm, whatever it is. Then you get an output and then you can submit it. You can send it, right? So again, this template is very straightforward. You have a ROS master. You have the subscriber. You can also be the publisher. All right. So in Simulink, it's going to be something like this. So you will have your subscriber, right? You have your algorithm. We don't know what it might have, perception algorithm or control algorithm. Then after you generate a certain value, then you publish that. And everything here should be registered to your ROS, right? So once you publish this one, another nodes can read this. Okay. So it's either where you are familiar, right? Some people might be, okay, I'm really good at MATLAB scripting, then I'll use MATLAB scripting. For me, I in my automotive days, I usually use a lot of this, which is supervisory logic, right? And then low-level control would be like your PID control or advanced, let's say, fundamental controls, right? But it depends on where you are, you want to be. So let's go to one demo, right? Demo number 1, how to link it with ROS. So this is a video. When I send you the material, how's it? I would include the video as well. So just imagine you have a virtual machine. This is a virtual machine that is running currently Melodic, right? And Gazebo. So it means to say it's Ubuntu and there is a ROS package already installed in that Ubuntu platform. And I'm just actually sending a variable saying Docker hello world 32. So in this case, for your MATLAB side, if we follow through the template, right, we need to we need to specify the IP address in the first place. So if you would notice, this is the IP address of the virtual machine. I need that information, right? So once you have done that, next thing is you just want to know who is the what are the topics in that ROS. So this is the one, ROS2 topic list. This is the the signals that I can read. So Docker is the publisher. I will just subscribe to this one. So I just say ROS2 subscriber. I want to get the chatter. Then this is the information that I get from that chatter data. So now I can just say receive. Then I get the latest value of that. Okay, so this is still no Ubuntu. As what I mentioned, Ubuntu can still run in a embedded systems, right? Like maybe a Linux embedded for Raspberry Pi or Jetson Nano. So this one is just, I just create a for loop and I will definitely get that latest information. So it means to say this can be a system outside MATLAB and Simulink, and I'm reading that. Okay, so next one. What if it's now going to be a turtle bot, right? As I mentioned, your turtle bot is going to be a package. And you would notice here on the right, this is what we call as Gazebo, right? And it's a simulation environment. So when you have a simulation environment, as what I mentioned, Gazebo already supports turtle bot. So meaning you can put the robot there, and then you can build your environment. Maybe it's a maze, it's a replica of your office or your classroom. Then you can make the robot move across that plane. Okay, so in this case, I just have a very simple example wherein I first understand the ROS topic list. So if I run this section here, this is basically what the gazebo with the how is it, the turtle bot will give me, right? So you would notice command velocity, IMU, join states, odometer, and scan, and TF. Command velocity is like how is it, move forward or move backward, right? IMU is basically your gyro sensor and accelerometer. Odometer, I think it's more towards the speed, I think. Then scan would be your RP Lidar. This one is an RP Lidar installed there, right? So it can give me the scan. So if I run through the video here, so once you get to understand what are the topics within that robot platform, then I can, let's say, just get some information like odometer, and also, sorry, where am I? Yep. So I can go to like odometer, and then I can already get like position orientation of the system, and some other things that I can pull out. Then let's say I just want to command the robot, right? So it means to say I want to be the publisher. I need to send command val, and I just need to say linear is 0.2, angle it's 0.5. Then if I run that, it should send. So if I'm sending this one, right, this value, run it. Maybe I have a loop for that. If I run this, then this one would turn. So simulators and actual hardware would be the same, because the main point for ROS is that you just need to have the IP address, or the robot or the simulator is connected through the same environment. Okay. So again, these are provided, this velocity message, right, is provided by your robot makers, or if not, you need to build it here, right? So you would not, if you go through the topics and messages, I think this is where you can actually create your own how do you say it, publisher node and subscriber node, but you need to build that one. Okay, but as what I mentioned, your manufacturer or component or robot manufacturer would already provide you all these things. Otherwise, go back here, build this in C and C++. Right? Let's move forward. So what if now it's ROS2, right? So this is a high-level application of the system. So it means to say now I have a maze, I have the burger, the waffle turtle bot, and the waffle turtle bot has a camera. So first, you would also notice that there is a state machine here, but it's a very simple algorithm, right? You can add in different composition of the system, but again, it depends on the algorithm that you have. And the main goal here is that I'm just going to actually read the logo, and then you would have this scan. So in Gazebo or in ROS, right, these are the things that you need to be familiar with. This one, as what I mentioned, is Gazebo. This one is what we call as RVIS, right? So your Gazebo is the simulation environment. RVIS is your visualization environment in this space. So when we say visualization environment, right, means to say it's actually just going to read the topic or read the sensor data and visualize it for you. Doesn't do anything, but based on the application name RVIS is really just robot visualization. So this is your scan, but you need to do something with the scan, right? You need to understand what's the distance between the robot and the wall. But the robot doesn't know if this is a wall, right? But you need to come up with that idea. But that would be through this algorithm here in your MATLAB, right? So you have this, you would notice that I have been tracking the object, right? And then I know that it's turn left based on the application that I say turn in place, and then move further. And then yeah, if I move really forward, I need to move to another section, wait for it. Then basically I'm just like doing my autonomous things already here with image processing. At the same time, very simple control, right? Turn left, turn right, turn its on position, and so on and so forth. And at the end of the day, I'll just move forward. At the end of this simulation, definitely I can reach to the stop, right? But do take note, all of these things is running on a desktop. I'm not running it on a actual embedded device. I just have a emulation or simulation environment in Ubuntu, but I have my MATLAB running at the same time here. Okay, so let me go through the next one. So this is in Simulink perspective, right? But again, it really depends on where you are comfortable. So people can still run the algorithm in MATLAB perspective, but this is Simulink, right? So I have some algorithms here for the image processing side, and also since it's in Simulink, then it's more easier to maintain, right? So, but anyway, this is in perspective of a Simulink environment. Okay, so the last thing that you can probably do is generate whatever you have built in MATLAB or in Simulink to its own standalone C and C++. So what I'm saying here is that this is your Ubuntu, right? Environment, having ROS. This is pretty much your algo, right? Or algorithm, or robotic algorithm. But what we want to do is basically you will have another maybe system here. It's a Raspberry Pi. I'll just put our Pi here and bring this algorithm in the Raspberry Pi. So what's going to happen now is that, let's say this is going to be a Raspberry Pi, and it will just communicate through ROS. And that's where you can actually just deploy your algorithm out. So this means to say whatever you have built in MATLAB or whatever you have built in Simulink, we generate C and C++ there, and then we create standalone ROS node running on a Raspberry Pi. All right. So we can pretty much use that capability to build an actual application or an actual robot without even prototyping. Okay, so I'm actually near to my end, but is there some question? I'll try to answer some question.
Yes, Ian. Actually, this is a easy question, but I think you need to answer that question.
So there is a question, maybe explain earlier.
The last one.
Yeah, last one, right? Is MATLAB also installed in Linux? No, it's not a requirement. So what you would notice in the examples here, if I move back, if I alt tab, right, there are some videos that I have that I did some alt tab. Wait, where is it? I think I alt tab a bit. But if you think about it, this is, I'm actually running it in a virtual machine. This is my Windows. Okay, so it's not necessary, but when you deploy these algorithms out, it should be, I would recommend it's going to be in Linux. But when I did this one, when I ran this demo and prepared this one before, long time ago, I'm actually using Windows. But again, Windows is just a shortcut. Your material here, I posted this one in the chat, is going to be Linux, right? You can see what they did is basically you still need, if your PC is Windows, you need to download a virtual machine player, which is VirtualBox or the VM that I use here. Okay. But to really get started, right, is I would recommend to, if you do have access to MATLAB and Simulink, right, this one here, this robot model is actually here, ROS MathWorks, how is it, archive. Where is it? So we do have MathWorks Gazebo. Here, sorry. So to really get started, like you don't really need to like install them one by one. I would just recommend to follow this, like download, install virtual machine, the VMware player software, right? And then download the archive. Though this one is around, how's it? This is around 7 GB of file, but this one is already your Ubuntu. It already has the ROS package installed. It already has the Gazebo. It already has a Kinova, if I remember. Right, so it means to say you don't need to individually install the packages because it's already there, right? And you don't need to manually do sudo app install Gazebo, sudo app install ROS. You don't need to do that. So once you package this one, they will give you already all the necessary files to run. I'm not sure if I do have that VM. If I can still run it. I think no, I think it's not the one that I have. But let's say if you download this one, as what I mentioned, it's around 1.4. Not that heavy. But once you download this one, then I think you can already run your system. You can run already all these simulators that is available, because it's also a bit hard, right? When you start from scratch, this one is something that you need to configure, right? It's basically your environment. But let's say if you bought the robot from a commercial supplier, then normally they would already provide you a simple environment to work on and play around with. Okay. So going back to my slide, right? Again, we only talk about the ROS part, right? And just to summarize everything here, it's really about these things. Where do you want to use your tools, right? But again, for MATLAB and Simulink, you can do post-processing, right? You can do cost simulation and also deployment. So this is something that we are able to do right there and then. I think the difficulty is that since let's say you don't have MATLAB and Simulink, right? And controls, perception, planning, and decision making normally needs to be translated into C or C++. Or you can use Python. I think that's fine. But you need to have another modules for this. Let's say Python for OpenCV, right? You need to install that. Then you have Python for PCL, Point Cloud Library, right? You need to install Python for deep learning, probably if you're dealing with YOLO or that kind of stuff. You need to install certain packages for Python to run. But let's say you do have access to MATLAB and Simulink, and you do have access to some of these toolboxes that's able to do the controls, perception, planning, and decision making, then I think it's not that difficult to manage all these things, right? And again, the nice thing about this is that we can generate to C and C++. All right, so you might have control algorithms, you might have perception algorithms, you might have the planning algorithms in MATLAB, which is a high-level language. Then we package it into C and C++ so that your algo will be running independently without MATLAB and Simulink anymore. So your typical workflow in terms of developing these robots, right, is always like post-processing. Means to say you get the data, I want to analyze the data and create my algo from the very beginning. Next is probably you will have a hardware or a simulator version of that hardware. Then you do your cost simulation. All right. And then the last one, once you are okay with your cost sim, then why not deploy it? So we do offer this, let's say, at least the end-to-end workflow of developing our robot from scratch. Okay, so I'll send the material over. I think I put it in a chat, in a video perspective, so that at least you can look back and understand it again. Like, how do we go through and build the ROS communication with MATLAB and Simulink? All right. Any questions? So
Yeah.
far, yes.
You still have 4 minutes left.
Yeah.
Actually,
So
you want to continue answer the first question from Pak Siddiqui, or we want to spread another webinar or meeting with them?
I think, yeah. So I do have an RP Lidar. Right. Maybe we can have another session just talking to how do I bring in RP Lidar.
Sure.
So I do have this one. If I remember, I bought this RP Lidar from Ali. No, Seed Studio before. But I need to look for that hardware. But I know where I place it. So I have this one, not this one. This is the expensive one. But I have the small brother of this. But again, if I want to read this one, then it's through ROS, actually, right? So I think I have the cheap one because I just want to try out. But this one we can have maybe another session on how to set it up. Okay. Any other questions?
Untuk teman-teman mungkin yang dari ITS, kalau ingin bertanya silakan, kita masih ada. Okay. We have one question.
Yeah. So there's Turtlebot is compatible with all model of Lidar. So if I put this Seed Studio here, right, and I put another section here for Turtlebot. So your Turtlebot, when you buy it, it already has this Lidar. Okay. So meaning to say, you don't need to buy it. It's part of the robot. So once you buy it, it's already within that. But I think this one is already not produced, right? I think not anymore in production. I think now they just have the Turtlebot 3, but yeah, it's there. But when you say you have an RP Lidar, you plug it in. So what's going to happen is that, let's say you have this Turtlebot 2, right? This Turtlebot 2 has a Linux environment. You use that Linux environment, you plug it in. So basically it's a USB device. So if it's an Ubuntu Linux, right, and a USB, I think it should be compatible. But I think you need to try out. I'm not the LiDAR, I'm not the LiDAR seller, but you need to ask them. But generally, if I go to Wiki ROS RP LiDAR, then the requirement is only, what's the requirement? Install. They should have like ROS. No, not this one. So you will need to, what's the limitations? So you might need to look into the if it supports TTY USB, right? If it has this, if it doesn't have this, then I think you don't use that. It's the same. So if you go to China, it's the same. It's the same PCB. It's the same chips. So RP Lidar is just one of the brands, but it's basically the same components. Yeah, I understand there is like another brand for Lidar. Even people hack the, just to give you an idea, right? I have this Xiaomi robot vacuum. So a long time ago, since this is not available, right? People just open up this Xiaomi. This is a Lidar. And when I actually opened up for myself because I tried to fix my Xiaomi vacuum cleaner long time ago. It's the same. Is the difference is basically you will have this, how is it? They will provide you this small this one. So that one is the, how's it, something that you need to be worry about. So if it's not supported, but this is just basically the USB how's it, converter that you need to be careful of. Yeah, because this one is very standard, but this one is the one that they provide the SDK or whatever capabilities that they have. So I would still recommend to get the how's it, this RP Lidar, because I have used it. It's not that difficult to use, and then it works with ROS, right? Though the difference, right, is just 12 meters in range, and then the spin, sorry, the spin is just 5 hertz. So you have like less speed in terms of that. But if you go to the expensive one, right, then it has more capabilities lah. So it means to say 25 meters of range radius, and then you will have like the sampling rate is a bit fast, so it's spinning faster. Okay, but it supports how's it? It supports ROS as well, but the price just goes up, right? So it's like 500, 600 USD. That's very expensive. Okay.
All right, then. So
Yeah.
we still have another question from Pak Sidiki. The last question, I think.
Which one?
Last one. You already answer?
Yes. Yeah. Yep. So again, for Turtlebot 3, they already have the sensor. So it means to say, again, this, right, would be, if I go back to my slides here, then if I move forward here, sorry, this one would have the scan, right? Where's the scan? Give me a sec. So there is a scan function for this one. So it means to say it already has the RP Lidar already. So you don't need to say that there is a YD Lidar X4 there, but they already provide you the topic for it in ROS perspective. So it doesn't matter what Lidar does the Turtlebot use. Okay.
Oke. Pak Sidiki, gimana Pak? Sudah terjawab untuk pertanyaannya?
Sementara sudah sih Pak. Yeah, I think it's kind of clear.
Okay, so again, the most important thing here is that once you have the Turtlebot, so this is the waffle, right? It's T-bot 3, right? Once you know that there is an RP Lidar or whatever brand it is, you need to get its how is it, the imagery or whatever topic it has, and one of the topic is scan. So they already create the due diligence to write their own functions for the scan for that. Okay, so you don't need to like write all these things because they need to build this one for you to create a topic. Okay. All right, guys, so far so good. Yeah, so I think I will forward you the slides. I will also add in some links as well. So Bang Bang will forward it to you guys so that at least you can come back and try. And then probably Bang Bang, we will set another schedule. Just let's say setting up with an RP Lidar. Okay, just to be specific in terms of the actual reading of the ROS. But I need to set it up. So give me maybe 1 week to set up that demo.
Sure, Ian. We will let you know about that.
Yeah.
Okay. Jadi, oh yeah, sorry, Ian. So you already finished for your presentation, right?
Yep. Yes.
Oke. Oke. Jadi mungkin untuk teman-teman dari ITS, sekali lagi saya ucapkan terima kasih untuk sesi keduanya. Ini mengenai ROS, sepertinya lebih seru dibanding sesi pertama kemarin yang masih basic ya. Jadi kembali lagi mungkin saya ingatkan untuk teman-teman yang mau lebih detail lagi mengenai ROS ataupun ada project yang sedang dikerjakan. Jadi mungkin bisa nanti menghubungi Bu Dini atau mungkin nanti kita set up ulang untuk meetingnya yang khusus membawahi masalah ROS. Dan mungkin untuk informasi juga bahwa kita masih ada satu sesi lagi di minggu depan di tanggal 31 jam 2 siang juga seperti sekarang. Ini sesi ketiga kita membahas mengenai path planning and navigation for autonomous robot. Jadi mungkin jangan sampai kelewatan untuk teman-teman ITS untuk mengikuti sesi terakhir kita. Gitu ya. Mungkin saya masih turn off. Ya. Ya, jadi mungkin Bu Dini ada yang mau disampaikan sebelum kita akhiri nih.
Iya, mungkin kita perlu foto bersama ya, Pak.
Itu betul Bu Dini, terima kasih mengingatkan. Mungkin untuk teman-teman dari Texas boleh dinyalakan kameranya. Ada Junje dan
Bapak Ibu, monggo untuk menyalakan kamera dan rekan-rekan mahasiswa silakan berkenan menyalakan kameranya.
Kita bukan selfie ya, wifi kalau begini.
Nah. Baik. Apa seadanya saja ya, Pak?
Ya, siap.
Ya. Oke.
Yang mau hitung Bu Dini atau saya, silakan.
Iya, boleh 1. Saya 2, 3.
Oke.
Baik. Terima kasih.
Oke. Jadi mungkin sekali lagi terima kasih untuk teman-teman dari ITS untuk waktunya. Jadi mungkin kembali lagi sampai bertemu lagi di sesi kita yang terakhir di episode ketiga. Dan saya ucapkan terima kasih untuk Bu Dini atas bantuannya selalu untuk setiap eventnya. Jadi sehat-sehat untuk teman-teman ITS. Selamat sore.
Ya, terima kasih Pak Bambang. Thank you, Mr. Ian, and see you next week.
Yeah,
Thank you for sharing your knowledge.
Thank you, Ian.
Bye. Bye, guys.
Bye-bye.
Ya, bye-bye.